Ron Burgundy here with Melbourne, Australia's Evening News. Up next, we have Keenan Flegel with the weather report, followed by Justin and Kiffle with a hot story on ozone depletion.
Here we are in Melbourne, Australia, and it is bloody hot. It seems as if 3 out of every 4 people passing by are red as a fire truck. The temperature is 94 degrees and the sun is blazing. There's a line out the door at the Skin Cancer Centre, and the Sunglass Hut sure is doing some pretty good business. The ozone depletion is really becoming a hot topic as protests against CFCs and nitrogen oxides are becoming increasingly common. Efforts are being made to have laws against aerosols and other products that are harmful to the ozone that has already experienced severe depletion over Australia.
Thank you to our weather reporter, Mr. Flegel, for the informative report. I'm here with our co-analyst, Mr. Massey, to discuss the significance of what Mr. Flegel was alluding to. We live on a very special and unique planet, Earth. Earth has an atmosphere that is chemically active and very rich in oxygen. What is the significance of oxygen, you might ask? Well, the two forms of oxygen, O2 and ozone, O3, play a vital role in protecting us from the sun's UV rays. The different forms of oxygen exist as O2 double bonds, as well as O3, in which the oxygen to oxygen bond is between a single and a double bond. The layers of gas above our heads form the life support system of our special planet. We should think of the ozone layer as our friend, a friend that wants to protect us from the potentially detrimental effects of the sun's UV radiation. Wouldn't you agree, Mr. Massey?
The amount of actual ozone in the ozone layer has been decreasing according to concentration measurements in the stratosphere, and it all comes from pollutants. Two main examples of pollutants are nitrogen oxides and chlorofluorocarbons, or more easily said, CFCs. These two pollutants act as catalysts for the decomposition of the ozone. When's the last time you flew at hundreds of miles through the air? Well, jet aircrafts inject those same nitrogen oxides directly into the ozone layer because of the combination of nitrogen oxide and oxygen in the engine. There's been a buildup of CFCs in the atmosphere. CFCs are used in many things, most commonly being aerosols, refrigerants, and plastics. CFCs are most present in the troposphere, and they eventually diffuse into the stratosphere where they get exposed to high energy UV radiation.
Thank you, Justin. Those anthropogenic sources sure aren't helpful. The stratosphere is the second major layer of the Earth's atmosphere, and we can think of this layer as being stratified in regards to temperature. For example, the warmer layers are higher up and the cooler layers are farther down. The absorption of UV radiation determines this aforementioned relationship in this layer of the atmosphere. The more UV radiation that is absorbed in a number of photochemical reactions, the more the temperature rises. In understanding the essentiality of ozone depletion, I think we should discuss the famous Chapman cycle. This cycle of reactions is extremely important because dangerous UV light is absorbed and the stratosphere becomes warmer. Both of these processes are vital for the survival of the Earth. In the stratosphere, the strong covalent double bond in normal oxygen is broken by high energy UV radiation to form 2 oxygen atoms. These oxygen atoms are unique. They have unpaired electrons. We give these reactive oxygen atoms a special name, free radicals. The rationale behind this is that the free radicals react with another oxygen molecule to form ozone. This part of the process is exothermic, and so the temperature of the stratosphere is increased. As a general rule, the bonds in ozone are weaker than the double bond in O2, so UV light of lower energy is needed to break these bonds. The oxygen atoms then react with another ozone molecule to form 2 oxygen molecules. This is another example of an exothermic reaction. So much energy is being released, I cannot even believe it. Heat is produced and maintains the relatively high temperature of the stratosphere. The level of ozone in the stratosphere stays at a remarkably constant level if the rate of formation of ozone is balanced by the rate of removal. This is known as the steady state and is one of the key principles in the topic.
Through the ample use of CFCs, they are predicted to remain in the atmosphere during the next century because of their low reactivity. Chemists, using their knowledge of molecular structure, have come upon possible replacements, such as hydrocarbons like propane, can be used as refrigerant coolants. The presence of a hydrogen atom instead of chlorine prevents the compounds from decomposing as easily. The replacements have similar properties but have fewer C-Cl bonds, which is the problem with CFCs now.